Well, hey there, it's John here, and I'm back at the Hands-On Discovery Center with another activity that you guys can try right at home. Today, we're going to be creating complex geometrical shapes that actually are kind of mind-blowing when you think about it. We're going to make a shape that has one single surface. When you think about like a cube, it has top, bottom, and 4 sides for a total of 6 surfaces, but this shape only has one. To make it, you're going to use something that actually has 2 surfaces. Paper. Take a piece of paper, it could be cardstock, it could be printer paper, and cut it into nice long strips. First thing we can do is to create a normal loop just by taking your piece of paper, your strip of paper, and taping the 2 ends together. Nothing super fancy here because it's just a traditional loop. But remember, I said we're creating a shape that has one surface. This one obviously has 2. The outside surface that has green color paper, and the white on the inside. 2 different surfaces. So this is not our magical one surface shape, so get out of here. Instead, when we tape our piece of paper together, you aren't just going to tape it in a normal loop. You're going to take one side and give it a half turn over. That way, as you're following around the outside and inside surfaces, you'll notice the purple runs into the green, follows along that entire green face, and then turns into, on the inside here, purple. So you're actually traveling from the outside loop to the inside loop, creating one single united loop. This is called a Mobius loop, or a Mobius strip. And while it's super cool to look at and think about, how you turned a 2-sided piece of paper into a one-surface piece of paper, things get really more interesting if you were to take this loop and cut it in half. And I don't mean just like snipping along the edge, because that's just going to unfold the loop and you're going to have a strip of paper again. Instead, we're going to cut it down the long way, just directly in half. Think about what would happen if you took a normal loop and just cut it down the middle. Well, you'd take that one loop of paper and make 2 kind of shorter loops, but not so with the Mobius loop. Here, you'll want to kind of pinch your loop together and just start cutting a little ways in there to get the cut started. Now, using your scissors, just continue all the way along the length of your Mobius loop. You may have to kind of zhuzh or help the little loop along, because sometimes it'll get a little caught up. But once you're all the way down the length of your loop, you can then go ahead and take your loop. What? I thought I cut it in half. Our Mobius loop, when we cut it in half lengthwise, still remains as a single loop. But this time, you'll notice here, not just a half turn in our new Mobius loop, but a full turn over. So this, just by cutting in half, has actually created more loops and twists in our new Mobius loop. Very cool. But what would happen if we did a trisection, or cutting it into thirds? For that, I'm actually going to use this long ribbon paper because it's going to be a lot easier to cut. Again, when we loop our ends together, we're not just going to tape them in a normal loop. We're going to take one side, give it that half turn to create a Mobius loop. Tape it together. Let's tape it on this side, tape it on the other side so it doesn't fall apart on us. And this time, we're going to do a similar process where we pinch the loop together, but instead of going right down the middle, maybe eyeball it 1/3 of the way across. Then repeat the process, continuing this cut about 1/3 of the way from this edge. And here's where it gets a little tricky. Once we get back to the original start, you'll notice the first part of our cut has now transferred or moved over to this edge of the loop, whereas we're still working on this side. If you were to cut across and connect these, you'd actually create just a single bisection again, and we don't want to do that. We want to do a trisection, cutting it into 3 sections. So instead of connecting it with that start of the cut, we're going to keep going along this way, cutting it again into kind of thirds, 1, 2, 3 sections, and just keep cutting. Now we've reached the beginning again when we finish this last cut and expand our loop. Whoa. Whoa, what? We obviously have a big loop here, but connected, interlaced with it, is a second loop that's freely movable around this larger loop. So by trisecting this Mobius loop, we've actually created 2 baby loops. So at home, guys, you can try experimenting with these Mobius loops. Instead of just doing 1 half turn, what if you did 3 half turns? A turn, and a turn again. Turn this activity into a really cool science experiment. Also, if you do like this activity, be sure to hit that thumbs up button and subscribe to our channel so you never miss a new video upload. And check the description below. There might be some cool information about how you guys at home can help us keep the science alive. But I think I'm going to go make a really epic, big Mobius strip. Bye, guys!